Hello everyone, welcome back again to Embed System course. So we are in chapter number 2, that is 805 timers and serial port programming in C. So in previous lecture, that is lecture number 8, okay, we started with part 2, that is serial port programming of 8051 microcontroller in C. Okay, so in previous lecture, we studied basics of serial communication, and we discussed how to connect 8051 serial port, that is TXT and RXT pins, with RS232 port, that is serial port, that is available in the form of RS232 port on personal computers or on so many other uh, devices. Okay, so these 2 points we discussed in a previous lecture, and in this lecture we are starting with serial port programming of 8051 serial port. Okay, so in this lecture number 8, we are going to study serial port mode 0. Okay, that is 8-bit shift register mode. Okay, so this mode 0 is not actually UART, that is universal asynchronous reception transmission. Okay, so it is simply a shift register mode, or we can call this mode 0 um, shift register synchronous mode. Okay, because 8051's serial pin will get synchronized with external device while shifting data out and shifting data in on 8051 serial port. How that we are going to study. So this serial port mode 0, that is 8-bit register shift register mode, that can be enabled by setting SM0 and SM1 bits from SCON SFR. Okay, so in previous lecture we studied format of SCON SFR. In that there are to set a mode, there are 3 bits, SM0, SM1 and SM2. Out of this, SM2 bit is used only if we are working in a multiprocessor environment, means more than one processor or microcontrollers are there in the embedded system. So in that case, SM2 bit is used. Okay, so if single micro controller is there in your embedded system, then there is no use of SM2 bit. So we have to program only SM0 and SM1 bit to configure serial port of 8051 in various modes, that is mode 0, mode 1, mode 2 and mode 3. So this shift register mode, that is mode 0, can be configured uh, by making SM0 and SM1 bits in SCON SFR 00. Okay, uh, and we can do reception and transmission of data using only one pin, and that is RxT pin. Actually there are two pins are available as a serial port of 8051, RxD and TXD pin. Okay, two pins are there. RxD pin is used as um, that is pin for reception, and TXD pin is used for transmission. If we configure serial port of 8051 in UART modes, that is mode 1, mode 2 and mode 3, but in mode 0, reception and transmission can happen only on a single pin, and that is RxD pin. In that case, pin TXD is connected to internal shift frequency pulse source. Okay, so on TXD pin, in that case, if we configure 8051 serial port in mode 0, we will get that is pulses on TXD pin. Okay, and these pulses are generated internally. Okay, so it is called as TXD is connected to internal shift frequency pulse source. Okay, to supply shift pulses to external circuit. Okay, means this RxD pin, we are going to interface with external circuit with which we want to transmit or receive data serially on this RxD pin. Okay, so to have synchronization between reception and transmission, okay, between 8051's RxD pin and external circuit that is connected, this RxD pin is connected to. So to have synchronization, these pulses these are internally generated on TXD pin. Okay, so that means this TXD pin acts as source of frequency pulses, okay, to external circuit. Okay, so that we can have synchronization, so that reception and transmission of bits is possible. So this frequency, okay, so this shift frequency, that is the rate at which the data bits will be shifted on RxD pin. Okay, so that shift frequency is equal to F crystal divided by 12, means whatever crystal oscillator we will connect to 8051 divided by 12. Okay, means in this period of this frequency, one bit will get shifted on RxD pin, or one bit will get received on RxD pin. That is the meaning. Okay, so these shift frequency period consists of 12 clock pulses of frequency F crystal. That is the meaning. Okay, so that is actually machine cycle of 8051, which consists of 12 clock pulses. Okay, so these 12 clock pulses can be divided into six states, in which each state consists of two pulses. Okay, so 6 multiplied by 12, 2, that is 12. Okay, so S1 to S6. Okay, six states are there uh, in a 12 clocks, and each state consists of two clocks cycles. Okay, so this TXD shift clock frequency, in this TXD shift clock frequency which is being generated on TXD, it will be low for machine cycle test states S3, S4, S5, and it will be high for machine cycle states S6, S1, S2. Okay, so this we can explain diagrammatically so that you will understand. Okay, so in a mode 0, that is 8-bit shift register, we can receive or transmit data only on RxD pin, and in that case TXD pin, on this TXD pin, frequency pulse source is generated of frequency F crystal divided by F crystal or FOSC divided by 12. Okay, and that shift frequency is like this. Okay, so that I will explain in next slide. So see here, so this okay, so so these S1, S2, S3, so this is one machine cycle, that is 12 clock pulses, which consist of six states: S1, S2, S3, S4, S5, S6. And in each state there are two pulses. Okay, clock pulses. This is one clock pulse in, that is P1, and this is another clock pulse, that is P2, and such P1, P2, P1, P2, P1, P2 are there under each state. So these two periods or two clocks, that means one state. As such, six states are there. Okay, and in each state there are two clocks, that is P1 and P2, P1, P2, so on. Now as I told you, so during transmission of data, okay, on RxD pin, data will be shifted out. Okay, and this data changes on the falling edge of S6P2, means S6 means this state number 6, and P2 means what? That is this P2, and falling edge means what? This is the falling edge. Okay, so data changes on RxD pin on each P2 falling edge in S6 state. Okay, that means here, see here, there is a data. What we will do, we will for example, we want to transmit 0 or 1 on RxD, that we will put on RxD pin, and that data will be there for whole S1 to S6, and that data changes to next data bit. Okay, during falling edge of this P2 in S6. That is the meaning. Okay, and see here, this on TXD pin. Okay, TXD pin, which is connected to external circuit to have synchronization, okay, with shift clock produced on RxD, that is the rate with which data is being outputted on RxD. To have synchronization with that data, whatever clock frequency that is being generated, okay, so that will generate on TXD pin, and that will be connected to external circuit to which RxD pin is connected. Okay, so these clock that is shift clock pulses produced are like this. Okay, so this is the shift clock produced on txt pin, so it will remain high, okay, for s1 s2 and s6. Okay, so that is written here, it will be high s1 s2 s6, that is states s1 s2. Okay, see here, from s1 to s2 and s6 it will be high, and it will be low for s3 s4 s5, that is during this time it will be low. Okay, that is during s3 s4 s5. In this way, these shift clock frequency will get generated on txd pin, and which is connected to the circuit with which 8051 is transmitting data with rxd pin. Okay, so during transmission, what happens, we will put data bits to be transmitted on rxd pin sequentially. Okay, so one bit will be remain on this rxd pin for one machine cycle. Okay, and that bit changes to next bit, okay, during falling edge of s6, that is the meaning. Okay, and it is job of external circuit to read in that bits that is available on rxd pin. Okay, so that is here, this is actually this period is nothing but one machine cycle, that is this consists of 12 12 clock pulses or 6 states. Okay, and see here, for this whole period, d0 bit will be transmitted, then d1 will be transmitted, then d2 d3 d4 d5 d6 d7, etc, so on. Okay, and this is the shift clock frequency that will get generated on txt pin that is connected to external circuit. Okay, so in this way transmission happens in this mode 0, that is shift register mode. Okay, so it is not called as UART, that is universal asynchronous reception transmission, because these bits we are transmitting, that is d0 to d7, that are not being framed in between start bit and stop bit, so this is not real asynchronous serial communication. So this mode is called as 8-bit shift register mode. Okay, so whatever data bits we want to transmit, these 8 bits we will load into sbuf. Okay, and when we load these 8 bits into sbuf, what will happen, these 8 bits will shifted, okay, sequentially on rxd pin. Okay, with rate, that is with rate of f oscillator divided by 12, means in one machine cycle one bit will get shifted on rxd pin. Okay, so this is called as shift register mode, 8-bit shift register mode, or it is example of synchronous communication, because 8051's that shifting frequency, okay, that is the rate at which data will be shifted on rxd pin. Okay, that is matched by using the shift clock being produced on txd pin. So this txd pin will be connected to the external circuit to which this rxd pin is connected, so that there is a synchronization while reception and transmission of data bits between 8051 and that external circuit. So mode 0, serial port mode 0 means actually synchronous serial communication. So this thing will happen during transmission of data. Now next part is reception of data. So data is received on same pin, that is rxd pin. Received data should be synchronized with shift clock produced at txd pin, means reception, whatever reception happens on rxd pin, that is in synchronization with clock being produced on txd pin, and data is sampled on falling edge of s5 p2. Okay, s5 means state 5, means this state 5 p2 falling edge means here. Okay, that means when this shift clock that is being produced on txd, when it switches from low to high, okay, due to this data will get sampled on whatever data available on rxd pin during reception. Okay, that is the meaning of data is sampled on the falling edge of s5 p2. External circuit should be in synchronization with this timing. Obviously it will be because txd pin is connected, okay, as a clock source to that external circuit. Okay, and this figure depicts the reception of data in mode 0. So these are the machine cycle frequency, means this period or this period. okay, is equivalent to 1 machine cycle. Means this these are actually ALE, address latch enable, that will produce 2 pulses. Okay, and this period of these 2 pulses of ALE, address latch enable, is equivalent to 12 clock pulses. Okay, so during these 12 clock pulses, one bit will be received. Okay, and when this bit will be received, see here, during this machine cycle, that bit will be sampled. Okay, during transition from low to high of this shift clock pulses being generated on TXT pin, that is nothing but falling edge of P2 in S5 state. Okay, so when this TXD changes from low to high, okay, whatever data available on RxD pin, that will get sampled and that will get shifted in S buff register. In this way, all the bits, okay, that is bit number D0 to D7, that is 8 bits, will get received inside S buff during 8 machine cycles. ओके, 8 मशीन सायकल झाल्यानंतर 8 बिट्स रिसीव्ह होतील आणि ते कशामध्ये अवेलेबल होतील? इंटरनली एस बफ मध्ये. सो दॅट कम्प्लीट्स रिसेप्शन ऑफ 8 बिट्स ऑफ डेटा in mode 0, and that 8 bits of data is available inside SBUF. Okay, so in this way reception happens. Okay, so now, baud rate of this serial mode 0, already we discussed the rate at which reception and transmission happens in mode 0, that is called as baud rate. Okay, and that is fixed because that frequency used to shift data out or shift data in, that is equal to f crystal divided by 12, that is f oscillator divided by 12, that is the frequency of crystal connected to 8051 divided by 12. That is the rate with which data will be shifted on RxD pin or data will be received on RxD pin. That is the rate. Okay, and same frequency clock pulses will get produced on TXD. Okay, to supply shift clock frequency to external circuitry with which 8051 is serially communicating. Okay, means transmitting or receiving data from. So for example, if that crystal frequency is 12 megahertz, then baud rate will be 12 megahertz divided by 12, and that is equal to 1 megahertz. Means 1 megahertz is nothing but 1 mbps, means 1 megabits per second, means data will be shifted with the rate of 1 megabits per second. Okay, shifted out or in, that is equal to 10000000 bits per second. So this is the baud rate with which that reception and transmission happens in mode 0 if crystal frequency is 12 megahertz. Okay, so this is mode 0. So we are not going to study programming in mode 0 because our interest is in asynchronous reception transmission of serial port of uh, 8051. So we are going to focus our study on mode 1 onwards, or more specifically we are going to focus our study on mode 1 because mode 2 and mode 3 are 9-bit UART mode. Mode 1 is 8-bit UART mode. Okay, in which data bits, number of data bits to be transmitted or to be received are 8. Okay, so we are going to focus our study on that mode 1. Okay, and mode 2 and mode 3 are 9-bit UART with fixed baud rate and variable baud rate. So in 9-bit UART mode, there are number of data bits are 9. Okay, so right now we don't need to have 9 bits of data, that is to serially transmit or receive. So we are going to study programming mode 1, that is 8-bit UART with variable baud rate. We can also set baud rate. Okay, so this is about mode 0, that is 8-bit shift register mode of a serial port of 8051. Okay, so we saw how transmission of data takes place on RxD pin. Similarly, we saw how reception of data takes place on RxD pin, and then we saw how to calculate the baud rate. It depends on the crystal connected to 8051. So that crystal frequency divided by 12 is nothing but the baud rate of a serial transmission reception in mode 0 of 8051 serial port. Okay, so this is about mode 0. Okay, so this much is sufficient for mode 0. Any doubts, we can discuss in our live session. Okay, so I will stop here discussion on mode 0 of 8051 serial port. Okay, okay, thank you.